Okay, now we will discuss the discrete control system. For discrete control system, the parameters and variables may change at discrete moments in a time, with the parameters and variables themselves being a discrete, typical binary discrete, that is on or off. The changes are scheduled, for example, as a part of the work cycle and or executed either because the system has changed or because a certain period of time has elapsed. These two changes are called event driven changes and time driven changes. And event driven changes occurs when the system is altered for some reasons and the control reactors to this alteration by executing some actions in response. Examples of the event driven changes in manufacturing includes status changes of a changes for a production machine from being ideal to becoming active, which is triggered by the placing of a part into the machine work fixture, thus starting the automatic machining cycle, and parts continuing by the sensor on a conveyor belt, whereas the sensors once it detect a part triggered the movement of the conveyor. Time driven changes is executed using the time as the parameter of change, that is after a specific quantity of a time has elapsed or at a specific point in the time. The change occurs regardless of the status of the system as in the event driven change, but rather as a result of a time of, of the time constraint imposed upon the system. As a result, for time driven changes, the deployment of the accurate timings is crucial for the change to operate effectively. Examples of time driven changes in the manufacturing include a specific starting and ending time of shift workers, and the length of the time of a heat treatment is some manufacturing process. Now coming to the computer process control, with the advent of digital computers and their initial explosion in the continuous process industries in the late 1950s, comes the concept of the computer process control. Previously, the analog controllers for the continuous control systems coupled with the relay systems for discrete control implementation or dominated manufacturing system control. These systems were gradually replaced by the computer system throughout the 1960s and 1970s as a computer uh, embraced one invention after the another. Today, with development of the computer microprocessor, we have a situation whereby the virtually all the industrial processes are controlled by one form or other of the computer process control based upon the microprocessor technology. The digital computers are programmed to coordinate and manage all aspects of continuous and discrete control of an automated system. The computer issues digital signals to accurate and receive the digital signals from the sensors. The computer continues with the non-digital actuators and sensors using the digital to analog converters ADC and analog to digital converters ADC. These converters are typically housed within the separate circuitry to the computer control, but together make up a control element of the control system. There are number of specific control requirements that are required if the computer process control is to be made operable. These requirements typically involve or revolve around the need to communicate and interact with the process on a real-time basis. A real-time controller is one which can respond to the process within the short enough time period to stop the onset of performance degradation. it needs to be able to handle more than one task simultaneously without letting them interfere with one another. This is called a multitasking. The control requirements to allow a computer or process control system to reach the real-time control are presented in given below table, dear students. Yes, this is the table control requirements by the computer process control. In first column we have process initiated interrupts. In that control description about this, the control must be able to respond to incoming signals from the process. This may involve uh, prioritizing tasks to be performed by the computer as the emergence of the higher priority issues must be uh, dealt with the first regardless of their order of appearance. A typical example is abnormal working conditions requiring the intermediate corrective action. And timer initiated actions, the controller must have the ability to implement these certain actions at a specific point in a time as necessary. The time intervals can be changed from the uh, milliseconds to several minutes depending on what action is being performed. Typically, the examples include the operation of sensors, switches, motors, and other binary devices in the process as necessary. And third one is a computer commands to process. The controller must be able to send the instructions to the process and have them obeyed. And the system and program initiated events, these related to the commands and instructions that are passed between the computer system to itself and to peripheral devices. System initiated even refers to the communication and the control between the network and the computer program. Initiated events refers to the communication and control between the computer and peripheral devices such as the monitors and printers. And operator initiated events, final one, the control must be able to accept the input from the operating personnel. Examples typically include loading new programs, entering the performance instructions, and requesting the process data and etc. Computer of control requirements are necessary to allow the computer process control system to reach the real-time control and include the process initiated interrupts, timer initiated actions, computer commands to the process system, and program initiated events and operator initiated events. The above controller requirements provide it with a number of important systems capabilities or specifications. These capabilities are outlined in given table. Okay, now coming to the other form of the computer process control. The computer can be used to control a process via process monitoring or process control. As the name suggested, in a process monitoring, the computer is used as a facility to collect the sufficient data from the process to build a picture of its operative performance. Whereas in process control, which in turn can be broken into open loop and closed loop process control based upon the delineation of the those terms made previously. The computer has a direct impact upon the process itself by acting as a regulator on its operation. As we can see the image, dear students, uh, yes, this is the various forms of computer process monitoring and computer process control systems that are in use today or listed in table. Mm, so as we can see the form, the computer process monitor, as you can see the computer process monitor, dear students, uh, the computer observes the collect and records the data on the process, but it is not used to directly control the process. Control is a human oriented, but use is made of the computer collected data in decision making for the process. Three types of data may be collected. Process data such as a process performance indicators, for example input parameters and output variables. Equipment data such as equipment status indicators, for example utilization metrics, breakdown data and etc. Product data performance metrics on a product type, volume or numbers etc, often required by the regularity bodies. And second one is direct digital control. One of the first computer control system no longer in use, but showed that way forward for a later invention, the first use as a more efficient substitute for the old analog control loop. It replaced much existing analog technology with the direct digital control facilitated by the computer. Later invention means that the concept becomes more than just a substitute for the outdated technology, and in time it is often offered the following benefits in its own right: more control options than the analog, that is more complex control algorithms could be used, integration and optimization of the multiple loops, that is it efficiently integrated multiple feedback loops and could optimize this strategy for new input parameters, and the ability to edit the control parameters, that it unlike the hardware of analog equipment, software control programs could be uh, reprogrammed and changed as a necessary. The direct digital control is a forerunner of distributed control system. Now coming to the numerical control and robots, the numerical control involves the use of the computer to direct machine to tool through a particular sequence of process steps defined by a program of instructions specifying all necessary details. Geometric calculations are also involved as the word part is processed in three-dimensional space. The robotics is related to the numerical control. A robot arm or a manipulator is controlled by the component of arm joints through a selected sequence of positions to carry out the work tasks during the work cycle. Typically, the arm works with other production equipments with which it may be in communication with. Again, geometric calculations are involved as the robotic arm moves through the various positions. And coming to the programmable logic controllers, this is a microprocessor based controller that uses the stored instructions in a programmable memory to implement logic, sequencing, timing, counting, and algorithmic control functions for controlling the machines and processes. And supervisory control, a control system that is tightly integrated with the lower systems of control to direct their overall operations in both the discrete manufacturing and in continuous process industries. Supervisory control changes the activities of a number of units or production machinery based upon predefined parameters of performance. The supervisory control generally has an interface with the human operations or operators, which allows it to be programmed to optimize the specific performance parameters such as economic or productivity metrics, which it can then monitor and oversee for the entire production unit. And coming to the distributed control systems, thanks to the microprocessor, control could become distributed to multiple computer systems and reintegrated as a necessary via a communication network to a central control room. In this way, the following benefits have arisen: the individual process control issues can be handled separately but still integrated at an overall level. Supervisory control could be run in the central control room to oversee the distribution control systems, and local operators stations could be distributed across the plant to take over the control activities at a local level or at an overall level should central control fail. The system can be easily extended or reduced as necessary. It was found to be ideal for multitasking purpose. It had a built-in tendency whereby other parts of the system could take over should a specific location's failure occurs. Uh, Capabling was found to be reduced when compared against the central computer control facilities, and the benefits of networking were felt the plant wise. Coming to the PCs in process control, PC implementation in manufacturing consists of a operator interfaces and direct control. As an operator interface, PCs can be connected as a peripheral devices or as a more integrated parts of the control system. In this capacity, in PC performs the human-led monitoring and supervisory function that can oversee all the control operations of programmable logic controls. The PCs can also be used for direct control. PCs in effect have made the concept of distributed control systems far easier to operate and to uh, populate, and with a general inexpensive of PCs. This can be done without the heavy financial outlay that was once required. The certain issues with early PCs, such as their insuitability for industrial environments, so have been solved, and this has allowed them to be seriously considered for the direct control process in the factory. And coming to the enterprise wide integration of factory data, the widespread use of the PCs of platter management structure, more administrative tasks done by the operators, and the deployment of extensive networking technology. All of these relatively recent innovations has led to a call for the greater consistency and coherence in the data that is produced in the factory. If possible, it should be streamlined, efficiently stored, and made available wherever and whenever it is necessary. And hope you understand, dear students. This is about the automation in manufacturing. uh, we will continue the remaining topics in the next session.